So now I need to integrate this over the region, a set of points x, y, such that 0 is less than or equal to x or less than or equal to 1. Well, you know what? I better start drawing a picture so I can figure out what I'm dealing with here. So x is going to be from 0 to 1. And y is going to be from 1 to 4. So what I'm going to have is this region. That is the region that I need to integrate over. And it's this function that creates some type of surface that's sitting above this. Let's see, make that y. That's sitting above this. And I'm actually looking for the volume between this region on the xy plane and reaching up to whatever this surface looks like. So the next thing I need to do is figure out what are my bounds of integration. What am I actually integrating to, and what order am I going to integrate? So I'm going to have a double integral, clearly, and this is going to be the square root of x over y. Now I need to ask myself, am I going to integrate with respect to x first, or y first, or what am I going to do? Well, I'm thinking I'm going to go ahead and do x first, no particular reason, just why not. So dx, and x goes from 0 to 1. That means I have dy, and y goes from 1 to 4. So now I can go ahead and just do like I normally do. The only difference between this problem and the other ones is it gave us dA and then define the area, and we're integrating over this region. And like again, this is the area, this is the region that we're working with. So we had to find the bounds based on the region as it was defined. So I'm going to do like I normally do. I'm going to take this inside piece. I'm going to work that out first and then move to the outside. So I need to integrate from 0 to 1 of the square root of x over y dx, which right away my thought process is this is the y is a constant. So I'm going to think of this as 1 over the square root of y times the integral from 0 to 1. And I'm going to write x, the square root of x, as x to the 1/2. Just so I can think of it a little bit cleaner, I guess. Dx. It's not that you have to do it that way. It's just that when I see this like this, that's exactly what I'm thinking. So I'm kind of writing and explaining what I'm thinking. So now I'm going to go ahead and integrate this. This is going to give me 1 over the square root of y times, this is going to be x to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. And I need to integrate this from 0 to 1. Well, that's going to give me 2/3 times y to the negative 1/2 minus 0. So this is now what I'm going to integrate. So that needs to go with respect to y from 1 to 4. So now I'm going to, whoops, there we go. Now I'm going to integrate from 1 to 4. I'm going to pull this 2/3 out. Y to the negative 1/2 dy, which equals 2/3 times y to the 1/2 divided by 1/2, which is the same as multiplying by 2. So if I'm going to simplify this a little bit, this is going to be 4/3 the square root of y evaluated from 1 to 4, which is 4/3 times square root of 4 is 2. Square root of 1 is 1, so 2 minus 1, which is 1. So that just gives me 4/3 as a solution.